Okay, ladies and gentlemen, this is your well-rounded math teacher, Mr. Pickar, and we're gonna do lesson 7.7 here, solving polynomial functions. We're gonna use graphing, quadratic techniques, and some other things. Okay. So a little bit of review. This is just greatest common factor, this middle one here. Basically, you take a 5 out of both of them, and it looks like an a cubed a squared. Well, I can take out an a squared out of both of them. And then the lowest power is a b to the 5th. So greatest common factor, GCF, 5a squared b to the 5th is what we're taking out of both terms. What would we have left? Well, 5 goes into 25 5 times. A cubed divided by a squared, you'd have an a left over, subtracting the exponents. And the b to the 5th and b to the 5th just cancel out. Okay. So we got 5a inside there. What else do we have? 5 goes into 5 once, 15 3 times, so that's 3. The a squareds cancel out, and I got a b to the 6th over b to the 5th. 6 minus 5 is 1, so that'd just be b. So there it is, greatest common factor. This is difference of perfect squares. We'll get to that in a little bit. General trinomial. Okay, so this is one we're kind of doing the x method. X squared x and a constant. A times c. So 2 times negative 15, that's negative 30. I want factors of negative 30 that add up to negative 7. If you list them all out, the largest one has to be negative. So 1 times 30, well, it'd be negative 30. That's not going to add up to negative 7. 2 times 15, that'd be negative 15. And 3 times 10. Okay, 3 and negative 10 add up to negative 7. So this is going to be 3. This is going to be negative 10. And they have to add up to negative 7x. So these are my x terms. Now, from here, you're probably going to do box method or grouping. I usually do grouping. 2x squared. I'll say plus 3x minus 10x minus 15. If you're doing the box method, it's the same thing. It's just a little organized, a little different. Take your first term, 2x squared, and your last term, negative 15. They go kitty corner from each other. And then the 3x and the negative 10x, it really doesn't matter. Okay? You check here, I can take out, it looks like a 2x. 2x times x is 2x squared. Here it looks like I can take out a 3. Going up and down in this last column here, I would say that's negative 5. So x minus 5 and 2x plus 3. I should get the same thing here with the grouping. I'm going to group these two together and these two together. I can take a 2x. Actually, I can only take an x out of both of these. So that's x times 2x plus 3. These are both negative, so I'm probably going to take out a negative 5, it looks like. So that's minus 5 times 5 goes into negative 10. That's 2 times, so that's 2x. Negative 15 divided by negative 5 is positive 3. These two binomials are the same, so it's 2x plus 3. And what I left with, what I factored out of these two, was the x and the minus 5. So that's my other factor. So you can see there's 2x plus 3, and there's x minus 5. So I don't care if you do grouping or box method. I'm going to do mostly grouping. So when I'm doing grouping, you can do box method on the side, okay? Either or. Difference of squares, perfect squares. A squared minus b squared equals a plus b, a minus b. Okay, so something like this might be, let's make sure I don't do the first one. Yeah, let's just do real simple. X squared minus 25. This is like a squared, b squared, because they're both perfect squared. X squared, the square root of x squared, that's the square root of x times x, so I can take out an x. So the square root of x squared is just x, and the square root of 25 is just 5. We know that, so they're both perfect squares. So you take the square root of them, I got 5 and I got x. That's what's going to make up my factors when I do difference of perfect squares. It should be perfect squares, but whatever. So it's x and x. Square root of 25 is 5 and 5. Now this wouldn't work with 24. 24 is not a perfect square, so I wouldn't do this method with any other numbers but perfect squares. And then you can see it's plus and it's minus. X squared plus 25, I cannot factor that. I can't do sum of squares, only difference. It's got to be subtraction, okay? I can do sum of two cubes and difference of two cubes. With these, here's the formulas, and I'll kind of go over the formulas when we do a couple of these problems. But basically, what you're looking for, let me see what I got here. I could probably do, yeah, let's just do this one. I'll make it easy. X cubed plus 8. I put 8 for a reason. The cube root, now I got a little index there. That's cube root. That means it's more than just a square root. If it's a cube root, I need 3 of the same things to come out. Well, looking at 8, that's 4 times 2, and 4 is 2 times 2. So I don't care about the 4, but there's 3 2's there. And I can pull that out, and that equals 2. So the cube root of 8 is 2. You can also do this on your calculator. There's a little cube root button to find perfect cubes. You can use that. That's probably a little bit easier when you get to the bigger numbers. But also x cubed, that's 3 x's right there. So the cube root of x cubed is x times x times x. I need 3 of the same factor in order to pull that out. Well, that comes out as x. So the cube root of x cubed is x. I need that. And the cube root of 8 is 2. I need that. You can see the cube root of a is a, so the cube root of x cubed is x, and the cube root of 8 is 2. So that's kind of what I'm working with. This is my a, and this is my b. In the formula now, I want a squared. Well, that's x squared. A times b, well, this is a times b. X times 2 is 2x. Now for this formula, it's minus. And then finally b squared. Well, that's the 2. 2 squared is 2 times 2 is 4. So that's kind of what you're doing when you're working with these, and I'll do a couple more of these to try and explain them a little bit more. It's the same thing for difference of cubes, okay? Except now, your first one, it's a minus b instead of a plus b right here. And this would be addition instead of subtraction. The last one's always addition for these formulas. So we'll do a few more of these, okay? So a lot of things going on here. Difference of squares, that should be easy. You've done that before. Sum of two cubes, difference of two cubes. Okay, so this one, well, I see an x cubed right away. The cube root of x cubed, okay? Because the formula we're going to use here is a plus b, a cubed plus b cubed equals. It's a binomial times a trinomial, and it's just a plus b. Basically, the cube root of these, the cube root of x cubed is x. There's 3 of them, you can take them all out. And the cube root of 125, that's actually 5 times 25, and 25 is 5 times 5, so there's 3 5s there. So that's just equal to 5, okay? So here's my a, and here's my b. So this is a squared, the formula, and I think it's minus ab and plus b squared. Okay. So we know what a cubed is x cubed and b cubed is 125. When I take the cube root of both of those, I get x and 5. So I'm going to put those in there. That's my a, that's my b. So to finish this off, a squared, well, square x. That's x, x squared, sorry. Minus a times b here for the middle term. Well, that's just x times 5. That's 5x. And then last term is b squared. Well, that's going to be 5 squared, or 25. There it is. That's your factored answer for sum of cubes here. Here's another sum of cubes. We already talked about 8. And you could take the cube root of 8x cubed. I guess so 8 is 2 times 2 times 2. And x cubed is x times x times x. So I'm taking out those 3 2's, that becomes a 2 on the outside, and those 3 x's become an x on the outside. So that's 2x. So the formula of difference of cubes is, it's going to be a minus b. This is a cubed minus b cubed equals, this is a formula for it. That's a squared, b squared at the end, and then ab in the middle. This is subtraction right here, so this one's addition. This is always addition. So I already got a, okay? A is 2x. Oops, I erased it. So my first term is 2x. Cube root of 27, I don't care that it's a negative. Well, that's 3 times 9, and 9 is 3 times 3. So I got 3 3's there. So the cube root of 27 is 3, or you can plug this into your calculator. Minus 3. Okay, so the next part, once you get the cube root of 8x cubed and the cube root of 27, those are your first two terms. You want a squared here. Well, that's going to be 2x times 2x. That's what 2x squared would be. So that's 4x squared. 2 times 2 is 4, and x times x is x squared. Plus AB, a times b. So we're going to multiply these two terms. 2x times 3 is 6x. I don't care that 3 is negative. Your signs are always going to be minus, plus, plus. And the last one is b squared. So I'm going to take my 3 and square it. Well, that's just 9. And there is my factored answer for difference of cubes. Okay, what else do we got? Okay, this is a squared. That's a perfect square. That's a times a. And 49. The square root of 49, now I'm looking at perfect squares. That's 7. 7 times 7 is 49. So that's just equal to 7. The formula for a squared minus b squared is just this. A and a, b and b, plus and minus. So now we're taking the square root, not the cube root. This is going to be my factored answer. So, hey, what's the square root of a squared? Well, that's just a. So this is a and this is a. What's the square root of 49? Well, that's 7. So it's plus 7 and minus 7. That's how you factor difference of perfect squares. Okay? So a lot of stuff going on there, but that's it. I could do another one. X squared. Let's do another one. X squared minus, I don't know, we did 25 already. How about 36? Because the square root of 36 is 6. So it's just going to be this. X and x, that gives you my x squared. 6 and 6 to get 36, but it's plus and minus. Difference of perfect squares, okay? This doesn't look like a perfect square, but it is. If I took the square root of x to the 4th, well, that's 4 x's. There's a pair and there's a pair. Take those out, I get x times x, or x squared. So x squared times x squared, if you multiply those, you get x to the 4th. That's what we're talking about there. Anyway, and then 81, square root of 81, that's just 9. So this is plus 9 and minus 9. And you would think you'd be done there, but if you look at this one, that's difference of perfect squares. If I said, hey, factor this, oh, hold on. X squared minus 9, well, 9 is 3 times 3, so that's a perfect square. So basically, I can factor that again. I cannot, and a lot of people try to factor this again because it's sum of squares. I can't factor sum of squares. But I can break this up into a plus b and a minus b, or in this case, x plus 3, x minus 3, okay? And that's it. That would be factored right there. Some you can factor again, some of these factors you can't. What do we got? We got 8 now. This is a little bit different. We're going to factor this using quadratic techniques, okay? You guys are used to ax squared plus bx plus c, where you do the x method where you multiply a and c, okay? A times c, and the factors have to add up to the b, right? I can do that same thing with this because this is x to the 4th, and half of 4 is 2, and then I got my constant. So I got a constant x squared and an x to the 4th. This power is half the size of this power. Just like this is x to the first and x squared. It's kind of the same thing. So we're going to use quadratic techniques. How I'd factor like a general trinomial and then kind of go from there. So this is 1. So a times c, that's negative 50. That adds up to negative 23. Okay? So 1 and 50, that's not going to work. 2 and 25. Okay, I want them to multiply to get negative 50 and add the negative 23, so the bigger one would have to be negative. 2 plus negative 25 is negative 23, so this is 2, and this is negative 25. Now, usually you put an x there, but this is x squared. That's got to add up to negative 23x squared, so I'm going to put x squared and x squared, okay? Now, grouping, take your first term, x to the fourth, then plus 2x squared minus 25x squared minus 50. That's your last term there. If you did the box method, you do the same thing. I'll probably do both of them this first time. X to the fourth, negative 50, first and last terms, and then what we got out of the x, negative 25x squared and 2x squared. Okay, so let me do this grouping one first. I group these two together and these two together. Out of here, I can take an x squared out of both of them, and that's it. So x squared, x to the fourth divided by x squared. Well, 4 minus 2 is 2, so that'd be another x squared. And that makes sense because x squared times x squared is x to the fourth. Plus, I'd just be left with a 2 here, okay? If I distribute this back through, I should get what I started out with. Anyway, negative 25x squared, negative 50, I'm going to take out a negative. They're both divisible by negative 25. So minus 25 times x squared looks like plus 2. These two are the same. X squared plus 2. These two factors make up 1. What you took out is the other factor, x squared minus 25. Okay. Before I go to the box method, I want to show you something. X squared and x squared are both perfect squares. Here I'm adding those, and 2 isn't a perfect square, so I couldn't factor this one again. So I'm just going to leave this as x squared plus 2. But guess what? 25 is a perfect square. That's 5. Square root of 5, 25 is 5. Square root of x squared is x. So I can do x and x, 5 and 5, plus and minus, because this is difference of perfect squares. And this is completely factored. Let's take this little box and go down here. So we got a little room to work with it. Okay, going across here, I got x to the fourth and negative 25x squared. I can take an x squared out of there. X squared times x squared is going to be this x to the fourth right here. Looks like 2x squared and 50 right here. I can take a 2 out, and guess what? That's that x squared plus 2 right there. And, well, going up and down here, negative 25 is what I'd take out. X squared times negative 25 is negative 25x squared. And remember, you can factor this again just like we did up here. So either you do grouping or box method, it really doesn't matter. Kind of works out the same way. And then you just got to check your answers and see if you can factor again. Sometimes you can, sometimes you can't. Okay. This one, I'm going to use quadratic techniques. I'm going to try and factor this like a general trinomial, because this is x to the fourth and this is half of that x squared, and this is my constant. So I can factor it, hopefully. This is 1. 1 times negative 63 factors of negative 63 that add up to 2. So now the larger one has to be positive. So 1 and 63, that's not going to add up. What do we got? 3 and 21, that doesn't work. How about 6? 6 times 7. 7 times 9, sorry. Getting all mixed up. They add up to 2. So this is my negative 7. Usually it's x, but now it's x squared they're adding up to. okay? If you want to do box, go ahead, box it up. This is x to the fourth, your first term, and negative 63, negative 7x squared, and 9x squared. Go ahead and do that. I'm just going to do grouping. X to the fourth minus 7x squared plus 9x squared minus the 63 at the end. Grouping these up. Boom, boom. Okay. I can take out an x squared out of the first two. Well, x to the fourth divided by x, that's just x squared. Here they cancel out and I get minus 7. Okay. These two, it looks like I can take a 9 out of both of them. Plus 9, x squared minus 7. Okay, so the one they have in common, that's one factor, x squared minus 7. And I can take out an x squared and I can take out a 9, so that's x squared plus 9. Okay, 9 is a perfect square, but it's addition. It's got to be difference of perfect squares in order to factor that. This is subtraction, but 7 is not a perfect square, okay? So you know what? I'm done. This is factored. Can't go any further than that, and that happens once in a while. Okay. Solving quadratics using quadratic techniques. Well, that's kind of what we just did, but now we're going to solve them. Ax squared plus bx plus c. We just multiplied a and c. A times c, and factors add up to b. Now we're doing ax squared, or ax to the fourth, sorry, plus bx squared plus c. But now we're setting it equal to 0. So once we factor it, we take our answers and set them equal to 0. Same thing here. We'd set our factors equal to 0 and solve. Once it's completely factored, of course. And we're still doing the same thing. A times c, that little box method, or I'm sorry, x method, adds up to b. But now my x squareds, I'm going to get here instead of just x's. Okay, so let's jump right into this. We don't need to do this one. You guys can do that one. This is the new stuff. So let's do this one. Okay, first of all, x to the fourth, x squared, and a constant. So I can use quadratic techniques for this, hopefully. 1 times 36, factors of 36 that add up to negative 13. Well, they both got to be negative. Both factors have to be negative here. So 1 and 36, not going to work. 2 and 18, nope. 3 and 12. 4 and 9. Okay, negative 4 and negative 9 add up to negative 13. So that's what I'm going to work with. Now, my middle term doesn't add up to x. It adds up to negative 13x squared. Like I said, if you want to do the box method, first term is x to the fourth. Last term is 36. Then throw in your negative 4x squared and negative 9x squared and break it down like that. I'm just going to do grouping. X to the fourth minus 4x squared minus 9x squared plus 36. Group these together right here and right here. Top one, I can take out an x squared, it looks like. So x squared. What do we got? X squared minus, these would cancel out, so that's just minus 4. I want my first term to be positive and second term to be negative, so I'm going to factor out a 9, but I'm going to make it a negative 9. And I get x squared, what do we got? Minus 4. These are the same. Awesome. And what you factored out is the other factor, x squared minus 9. Equals 0. But the key to this one is, looks like, well, I know x squared's a perfect square. That's equal to x, square root of it. And square root of 4 is equal to 2. So this is difference of perfect squares here. I can factor that one again. X plus 2 and x minus 2. Okay? 9's a perfect square. Square root of 9 is 3. So is x squared again. So I can break that one down also. X plus 3, x minus 3. Okay, now I just have to set all my answers equal to 0 and solve. So x plus 2 equals 0. X minus 2 equals 0. X plus 3 equals 0. And x minus 3 equals 0 and solve. Well, subtract 2 from both sides. I get x equals negative 2. Sorry, negative 2. Okay, well, here I'd add 2 to both sides, so that's x equals 2. Here I'd subtract 3, so that's x equals negative 3. And here I would add 3, right? Just do that one again. So there's my 4 answers. And I should have 4 answers because it's x to the 4th. Okay, what else do we got here? Here's another one. This one kind of works out the same way. I do have 1x to the 4th, x squared, and a constant right here. So I'm going to try and use quadratic techniques or general trinomial. 1 times 25, that's 225. Factors that add up to negative 34. Well, they both have to be negative now, okay? I don't remember. Oh. What do we got? 1 and 1 are 225. If they're both negative, they're not going to add up to negative 4. What else do we got? 3 times 75? Nope. 5 times 45? Nope. Does 6 go in there? No. 9. 9 times 25. Okay, those add up to negative 9 times negative 25 is positive 225. And they add up to negative 34. So these become my x squared terms. Okay, so like I said, go ahead and do the box if you want. X to the 4th minus 9x squared minus 25x squared. What else do we got? Plus 225. Group these two and group these two. I can only take out, x squared out of both of these. So that's x squared times x squared. X squared times x squared is x to the 4th. And then these cancel out, that's minus 9. I want my first term to be positive, second term to be negative. So I'm going to factor out negative 25. Minus 25. I'm going to have an x squared. And then minus 9, yeah. 25 times 9 is 225. These are the same. And what I factored out is my other set of factors. Okay, x squared is a perfect square, we know that. Minus 9, 9's a perfect square, square root of 9 is 3. So I can say this is x plus 3, x minus 3. This is x plus 5, because the square root of 25 is 5, so it's a perfect square. And x minus 5 equals 0. So it's kind of like the last one. Set them all equals 0. And x minus 5 equals 0. Okay, so if I solve this, I wouldn't add. I'd probably subtract 3 from both sides. X equals negative 3. Add 3, x equals 3. Subtract 5, x equals negative 5. And add 5 to both sides. X equals positive 5. There we go. That's it. This one's kind of it's a cube. So this is a little bit different. This is sum of cubes. Remember that, a cubed plus b cubed. Here's the formula for it. A plus b, and a squared, I think it would be minus ab plus b squared. So I got to take the cube root of x cubed. Well, that's x. So that's going to be my a. So if I write this down, let me rewrite this over here. I'll take it, yeah, that'll work. That's plus. That's x. Cube root of 64, that's 4 times 4 times 4, so that's plus 4. Okay, the rest of it, well, this is all equal to 0, so let me do that. Because we're going to solve this in a minute. There's my a, there's my b. A squared, well, that's x times x, that's x squared, minus a times b here, you're multiplying those two, so that's x times 4 or 4x. And then finally, b squared is the last one. Well, that's going to be 4 squared or 16. Okay, this one I can set equal to 0 right away. X plus 4 equals 0. That's easy. Subtract 4, x equals negative 4. You could factor this one all you want. The x squared minus 4x plus 16, setting that equals 0. That's not going to factor. It never factors when you do factoring sum of cubes. So we're going to use the quadratic formula. I'll put that in a different color. Negative b, x equals negative b, so that's going to be positive 4, plus or minus, because this is my b, a, b, c, when we're using the quadratic formula. I might as well write that out. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Okay, so b squared, that'd be negative 4 squared minus 4 times a is 1 times c is 16 all over 2a. So 2 times 1. A was equal to 1 right here. So this is 4 plus or minus the square root of, if you plug this into your calculator, what we got? 32, 64, 16, should be 40. That's actually negative 48 over 2. Okay. So this is going to be 4 plus or minus x equals, sorry. I got to simplify that square root of negative 48. Okay, take the negative out. That's an imaginary number, so that's I. 48, if you break it down, 4 times 12. 4 is 2 times 2. 4 times 3. 4 is 2 times 2. So prime, those are prime, those are prime. So basically, I'll put it right here, square root of 2, 2, 2, 2, and 3. There's already an I out there. I'm going to take out a pair of 2's. So I've got to multiply by 2. Take out another 2. And leave that 3 in there. So 2 times I, that's 4i. Square roots of, there's a 3 left there. That's not a negative 3. That's just 3. All over 2. Okay. One last thing. Divisible by 2, divisible by 2, divisible by 2. So if I reduce this, x equals negative 4 and x equals 2 plus or minus 4i divided by 2 is 2i, square root of 3. And this 2 divided by 2 is just 1. So these are my other two answers right there. That's it. If you have questions on the worksheet, let me know.